Hello and welcome to another episode of Space Update. I'm Ryan, Mr. Space Update himself. Joining me today is...
Hi, I'm Rich LB, host on Becoming Multiplanetary for Total Space Network. Come and catch me and Kage on our shows that release every Monday, where we talk about various topics on how to make humanity a multiplanetary species.
I'm Mikko, the host of Deep Dive Fridays.
And today we've got Robin Hague from Skyrora. Welcome, Robin.
Hello, thank you very much.
So we're doing things a little bit differently today, since we've got Robin on the show. So we're talking everything Skyrora today. Robin, do you want to give the guys a quick, brief history and rundown of who Skyrora are and what you guys are doing, just to give some of the guys that aren't aware of you guys what you're doing?
Yes, certainly. So Skyrora is a new launch vehicle company. We started in summer of 2017 and we're based in Edinburgh. So what we're looking to do is work towards the launch of small satellites from the prospective UK spaceport and wherever that ultimately may end up. To do this, we're working towards building a vehicle called Skyrora XL, which will be about 24 metres tall, approximately 2 metres in diameter, and capable of carrying just over 300 kilos into 550 kilometre sun-sync orbit from the UK. To do this, we're currently involved in a number of developmental strands, most significantly the in-house propulsion, where we're creating our own new engines based on hydrogen peroxide and kerosene, which we can cover in greater depth later on, which we believe gives us a number of advantages holistically in providing our planned future service for satellites going into space.
And you also got the Ecosene, that's just specifically for the XL rocket, isn't it, Robin?
Yes, so as a clean sheet launch vehicle design, as a whole new project, we want to minimise our ecological footprint as much as possible from the start. We feel consistently across the company that space technologies is critical for the science, and something that we want to be able to provide is sustainable access to space. We don't want the action of getting satellites, Earth observation sensors and instruments to be excessively negative. So part of this, when we have a very clean burning system, but part of it is that we have a project called Ecosene that is creating rocket-grade kerosene and intermediate options as well from non-recyclable plastics. So while it remains a fossil source, it is taking a greater waste problem and converting it, making use of a resource that would otherwise be a problem in its current state.
And correct me if I'm wrong, you need around about 600 kilograms to make something like 1,000 kilograms of fuel, something like that.
Something of that sort of order.
I remember seeing the fact sheet. I've got a bit ahead of the year on that one, so I've got the fact sheet to hand. You can create quite a decent amount of fuel within a short period of time. Creating that much fuel, I think it's in the space of 24 hours. The process is relatively slick, really, so if you needed fuel on hand, you could literally make it almost there and then within the day, couldn't you?
Yes.
And more recently, Robin, you had the Skylark Micro 1 launch, which I'd done the logo competition for a little while ago. That was obviously just a small, well, I say a small, it's a 3 metre high rocket, wasn't it? That one, which is essentially kind of like a sounding rocket, testing out hardware and other little bits for the future rockets. What did you learn from that launch and everything, despite losing the rocket?
It's always the most difficult thing is getting them back again rather than anything else. We're following a de-risking approach. We're trying to get as much as possible into practical tests as quickly as possible. And whilst the engine development is going on the ground, we have been launching a number of small rockets, just using commercially available solid rocket motors. So they're quite simple little solid powered fin guided rockets, but they're large enough to carry electronics and tracking and to begin testing those sorts of things out in a real launch environment. And a small solid rocket actually gives a tougher time to components. It's a harsher environment than they will be experiencing in the final bi-liquid vehicles. So we've done nano and micro. It was actually, we gave them those names because we decided to start naming in tribute to Skylark, the UK's most numerous launch vehicle, a large solid rocket-powered sounding rocket. Over 440 were flown between 57 and 2005. But as we were using this name to start off with, we felt we wanted to acknowledge that our little rockets were rather small by comparison to the scale of the final Skylark. So this is how we settled on Nano and Micro's name. Nano was a single stage, commercially available solid rocket propulsion, and then Micro flown thus far from Iceland, two-stage commercial solid rocket powered, standing just over 3 meters tall, pretty much 50% split in length, but obviously a lot more mass than the first stage, and that is capable of around 30 kilometers altitude. So we're still a way off space, but we're with that pushing beyond what people have done sort of privately in Europe. Although, of course, people have used similar technology on an amateur basis to get to those sorts of heights in the US, where they're fortunate enough to have the desert ranges within which to do them. Nano and Micro have been tremendously useful, both for flying the electronics, practicing the tracking systems on a smaller scale, and even actually for Micro going through the application process. It's become the first vehicle, small as it is, it's become the first vehicle to go through the newer UK application processes for the launch of rockets, and that has been very useful.
In terms of the UK laws for launching within the UK, I know you've done that Micro launch over in Iceland and everything. What stage is all the laws regarding the launches here in the UK at the moment, you know?
It's coming together. We haven't had a framework within the UK for space launch. There have been a small number of suborbital space launches as part of the government programs in the 60s and 70s from the UK. Skewer and Petrel rockets launched from the Outer Hebrides, and indeed I think there was possibly even a suborbit from Aberporth in Wales at one point, but nothing since then. And there have been some regulations in place for ambitious amateur rockets, which high power HBR type rockets have been flown under before, including something as large as the Top Gear Reliant Robin shuttle was flown under that basis. But now, because there are real space rockets coming down the plan, the UK has been putting in place the Space Industry Act to provide an actual framework for full commercial space launch. The first part of that is in place. It's had royal assent, but it is yet to get the legislation, if you like, the practical aspect of the legislation in place. It should be in place summer next year. That will provide the final framework for how things can go, how vehicles can fly to space from the UK.
So, Robin, I hear you're quite hopeful to be the first launch provider in Western Europe. Have you got any comments to make on that?
We believe so. Yes, we are optimistic that we will be able to get the first orbital flight from Europe. Quite a vibrant scene, of course, and there are some very creditable competitors who we believe we are well placed.
That's awesome. Actually, now we could take one viewer question. Framric is asking and actually saying that Skylark is awesome, but do you think that the UK Space Agency or UK government should be providing more incentive for UK launch providers in the same way as they do for smallsat business?
Well, they already are working very constructively towards the sector, and there is I know there has been some funding around as well as part of the National Space Technology Programme. So we have built up a very good relation with them, and they're most enthusiastic about ourselves and the other possible UK launch vehicles.
Hey guys, hoping you're enjoying the show so far. If you'd like to support what we're doing and join our Discord community, head over to patreon.com/Total Space. Once you're signed up, you'll have full access to exclusive content, interviews, and access to previous episodes. That's patreon.com/Total Space. Let's get back to the show.
One thing I've got to say is congratulations on, obviously, earlier in the year, you've done the first static fire in over 50 years. Earlier today, you announced that the third stage, that vacuum engine, is done and approved for the XL rocket.
Yes. Yeah, so we have been producing, started off with our upper stage engine. I always feel it's ironic. We've commenced with the engine we need last, But of course, it's the smallest one. It's the easiest place to begin. So that's the Leo engine. That's the engine that we performed our initial testing with at Spaceport Newquay, one of their hardened aircraft shelters, in summer 2019. It's there's an awful lot happened in between. It does. It feels longer ago, but we've just recently completed the program of tests on this engine with a gas dynamic tube in front of the engine which mimics the vacuum conditions so that we can test the vehicle in its full configuration before it actually gets up into near orbit.
And can you disclose the efficiency of that engine, Robin, or is it still all under wraps and everything?
It's excellently efficient.
Good answer.
We'll go for the Rolls-Royce approach. It's adequate, yes.
Well, I'm interested about it. I read the article about it too, and it was mentioning space taxiing and different orbits. And really the only mission I remember having going to multiple orbits is the SpaceX Falcon Heavy STP-2 mission back in 2019. And it had around 5 engine burns. So would your engine be able to do more burns?
Yes, so one of the advantages for using hydrogen peroxide is its very convenient relight capability. So hydrogen peroxide was something of a UK specialism, culminating in Black Arrow. Black Arrow is the peak of peroxide propulsion thus far until we fly.
The lipstick rocket.
Yes, indeed. So the performance of a given fuel with hydrogen peroxide tends to be a little bit down versus it with liquid oxygen. However, all sorts of other good things for us that when we're creating the system as a whole, we believe gives us an advantage. A major one being that it's non-cryogenic, so it's much easier to deal with. Not having to deal with cryogenic liquids is a big advantage. It's very dense. It's 35% denser than liquid oxygen. It's 1,400 kilos per cubic meter, and it's H2O2. It's water plus, so it runs at a very high mixture ratio. It's in terms of Black Arrow, it was actually 8-1 with kerosene. If you see a cross section through Black Arrow, it's almost all peroxide tanks. So it tends towards a simple, compact vehicle. And then if you force it through a stack of silver mesh, that extra oxygen springs off, it falls apart, the silver isn't consumed, it's purely catalytic, and produces 600 degree steam and free oxygen, as was done with Black Arrow. We have a catalyst pack in the top of our engines. To ignite the engine, it's just a question of carefully opening the hydrogen peroxide valve. You've all of a sudden got high temperature oxygen, and then you can open the kerosene valve and it will self-light. So there is no spark ignition or any ignition fluids, which presented problems for other developers. So it's simple and reliable ignition, which in terms of the third stage then means that we can very easily, say if we were to have a cluster launch of nanosatellites, we could put customers into the orbits they really want to, rather than having to just accept where a major mission took them to. The two biggest challenges when creating your own new biliquid rocket engines are the injector design and the turbopump. And peroxide helps us sidestep those, because with the injector, one of our propellants, is already a hot gas, which is then excellent for mixing with the kerosene. And we can run our turbopump as a steam turbine running off catalytically produced hydrogen peroxide steam. So we can make a very simple and effective turbopump. We don't have to deal with the mixing the propellants. We can run our turbine at a much lower temperature. And indeed, actually, we're cooling our engines with the peroxide because we have such a lot of it and it's such a good coolant.
Just spinning off the fuel mix and everything, Robin. The Skylark L rocket that used the peroxide and liquid oxygen mix, will you be doing another static fire of that rocket and potentially doing a launch of that one the next year or so?
So yes, we did the complete ground test of Skylark L in the Highlands earlier in the year, and as far as we know, as you mentioned, we believe it's the first one for 50 years. We think the last such test done was the Black Arrow first stage that ultimately flew on in 71. That seemed to have happened sometime around June or July 71. There's the possibility that there may have been a blue streak after that, but the last blue streak to fly flew in November 71, so it's all around that kind of time. So that vehicle experienced a complete test of everything except launch itself. We can reassure people that it was clamped down, bolted down, cabled down. It was definitely not going anywhere, but it was otherwise a complete replica of a launch. So that vehicle is essentially ready now. So we're working towards the options for launching it in the new year.
That one can essentially be launched from anywhere, isn't it? Like a modular system. It can be launched a bit, well, not to compare like a rocket launcher, but it's of that kind of size that it can be launched from almost anywhere, can't it?
Our ground infrastructure has been designed from the start to be very modular and simple and portable. So we make use of an awful lot of containerized systems. So for Skylark L in particular, it's very, very flexible about the launch site. Even for XL, it'll be an expansion of that approach. While we would be looking at more substantial launchpad installation, overall the whole system remains containerized. The prospective European launch sites have often used Mahia from New Zealand Rocket Lab's launch site as an example, but we feel there's an even lighter weight example, which is Falcon 1 when it flew in Omelek from Kwajalein back in 2008. There are some excellent photographs from that campaign showing how minimal they managed to create the launchpad system, and again, a very containerized approach for systems and ISO tanks for the propellants and this sort of thing.
Another question for one of the guys listening, Framric again there. He's mentioned the modular kind of design that Rocket Lab are establishing with their Photon kick stage for satellites and everything like that. I think Skyrora will go down that kind of route, obviously, in the coming years once XL's established and got a few flights.
Our third stage gives us that already because of its convenient reignition. We don't have to create another stage to go with it. It's already capable of it from the start.
Would you implement some customer satellites into the stage, like the Photon stage from Rocket Lab?
It's certainly something that we could consider in future.
In terms of testing the engines and everything, Robin, I think you've done over, nigh on 100 tests or something like that now, is it? Quite a lot.
Yes, we're building up quite a few. The majority thus far have been done on the upper stage engine, of course, as we were just talking about with the vacuum testing. But also we've now had a significant number of tests with our 3-ton thrust engine, which is the one that powers SKL that culminated in the ground test earlier in the year. The next step up from that is our 7-ton thrust engine, which will be clustered to power XL, and that's then our first turbopump engine. The 3-ton thrust engine is a very similar scale and shape, and we just have an increase in chamber pressure, an increase in nozzle exit area to move up to the 7-ton thrust engine. So again, it gives us step-by-step proving out the different bits that we're going to need for the final vehicle.
I have another listener question. This is from Eric X Space, who were featured in one of our latest shows. So he's asking, when did your interest in space start, and how did you even know where to begin with the company? And you can speak for yourself or the company.
For myself, I was an aviation enthusiast, and I was first into aeroplanes. And I realized, actually, funnily enough, discussing this recently, and I had not realized at the time, but actually the Rocketeer helped me get in this direction, much as that's not the same kind of rocket. And they misname it a rocket all the way through the film, whereas it's actually a jetpack. In researching jetpacks and things in high school led me towards the sort of jet engines and rocket propulsion information, which I'd not bothered to look at, but I was much more of a propeller person in my aviation enthusiasm. That progressively led me to rockets and launch vehicles and working in rocket propulsion. And I hadn't realized that until very recently. I was talking about that with somebody that it's down to the Rocketeer of all things. I ended up studying physics with space technology at Salford. As a student, I'd picked the space technology, and the physics just happened to come along with it. But that gave me the opportunity to do a research master's in hybrid rocket engines, actually, at that point, which led me to be involved with rocket propulsion for an X Prize team from the UK around the turn of the century. What feels like hardly any time ago, but is actually a distressingly large amount of time. We with that program, we did actually succeed in progressing up to 3-ton, 1.25-ton hybrid liquid oxygen rubber engines and 3-ton thrust liquid oxygen kerosene engines at the Health and Safety Laboratory at Buxton as the convenient place to test it. But of course, the X Prize was won by Mojave Aerospace Ventures, which became Virgin Galactic in 2004, and one of the problems with the original X Prize being that Mojave Aerospace were so much more greater resourced then the other 18 competitors that once the prize was run, won those projects really have tailed off. And so as that came to an end, the opportunities to be involved in launch vehicles in the UK was somewhat limited, unfortunately. Of course, given our sad accolade as being the only country to have developed the capability of putting things into space and then cancelled it. So in the interim, I was working then in design engineering for nuclear safety robotics, inspecting the bits of the power stations that's a bit too difficult, dirty or dangerous to spend a long time there as a person. And it's quite an interesting strand to be in. It's almost like designing planetary robotics, because you're creating something to operate remotely. And the last thing that I was involved with was a great project where we were creating actually snake robots for ITER, for the International Tokamak Reactor, that will be used to check out its liquid helium pipes once they exist for leaks. So that was a great challenge. But ultimately, fortunately, Skyrora came along and presented the opportunity to get back into launch vehicles, back into actual rockets, and it was conveniently remarkably close to home. So that was very fortuitous the way that came together. Skyrora overall has grown out of the new interest in space launch, the new opportunities of private space launch, and the particular opportunity of the UK. Starting, I think it was around 2010, the government noticed that the space industry, which has always been very strong, but not necessarily well recognised by the public or the government. It was noticed that the space industry had been growing successfully throughout the downturn. They had established the target of capturing, I think it's 30% of some aspect of the space market by 2030, and also an interest in UK space launch. So for Skyrora, we want to be able to fulfil that niche, because the UK having such a strong spacecraft and space data sector, if we can provide that missing link of access to space, then the entire space mission can be sourced by a client within the UK, and actually indeed within Scotland, with the spacecraft manufacturers in Glasgow, Space Data and Downlink with Dundee and Edinburgh, and then hopefully ourselves providing launch from Scotland.
Sure. Is anyone else got any other questions before we wrap this up in the next few minutes?
I would like to give Framrik a chance to ask a live question.
So I've seen the quality and the expertise in robotic exploration and reactor investigation systems from personal experience. The British have a reputation in the space industry of innovation and quality when it comes to communications, robotics, satellites. You know, we've signed up for things like the Artemis Accords and so on. Do you hope that your company and everything going forward, that one day that reputation will extend to the launch services we can provide as well?
I think so. I do hope so. Working hard to get to that point. I feel for ourselves, we have a very strong system. We have a good approach to it, and I think we'll be able to provide a very effective service. Of course, Orbex is the other sort of highest profile launch vehicle company connected with the UK. As yet, they've been very secretive in their information. We don't know how developed there is, how they're coming along. But I know some of the people involved, and I think they will do a good job too. You guys are working partially remote, and then all the guys in the workshop are still having to dredge in and do the work. Earlier than the lockdown, we were involved in creating PPE for hospitals and hand sanitizer as well, so that we could try and contribute sort of directly to the effort. We're fortunate with the workshop that we can arrange things so that people are well distanced. So we're keeping going as best we can and keeping as remote as we can. So it's doing okay so far. Thanks very much for joining us today, everyone. Thanks for listening, and special thank you to Robin Hague from Skyrora. No problem. Thank you very much for the invitation.
I've been Rich LB.
And I've been Mikko, the host of Deep Dive Fridays. Remember to follow us on Twitter, YouTube, and your favorite podcast platform. Last, I would like to say special thanks to our first patrons. So thanks to our first Patreon, Marco, as well as Susie, Framrik, and Gio. Thank you for your support. And if you would like to support us, check our Patreon page at patreon.com/totalspace or the description.
And we'll catch you next week. Thank you very much.